Well, howdy there, Internet students. Today we're going to do lesson 7.2c. We are going to learn how to graph equations given the slope and the y-intercept. So let's do a little race here to get started. Remember that the rate is the same as the slope. All right, so Sheldon runs at a speed of 2 meters per minute. So what we're going to do is they're all starting from the starting line. So at 0 time they have traveled 0. I'll do Sheldon here. And number 1 represents a minute, and since Sheldon runs 2 meters every minute, we're going to keep adding 2 for every minute. All right, so why don't you fill in the other 2 turtles? Slow-mo runs 1 meter per minute. Remember, they're all starting at the starting line, so at 0, they'll be 0. These will be proportional relationships. Okay, so hopefully you filled those in correctly. If not, go ahead and erase them and fix them. And now we're going to write the equations. Since these are proportional relationships, there won't be anything added on. So all we need to do is write the slope in front of the independent variable, which in this case is t, the time, minutes. So for Sheldon, the equation is going to be 2 times t, and t stands for the minute. So like 2 times 5. So make sure your equations work. 2 times 5 is 10. That works. All right, you do slow-mo and rocket. All right, now remember I'm a little lazy. You guys might have wrote 1t here, which would be just fine. When you're multiplying by 1, it doesn't change it, so there's an invisible 1 in mine. Okay, we need to circle the name of the turtle who wins the 10-meter race. So the person that gets to 10 meters first. I'm sure you can figure that out. Go ahead. Equals so m equals 2 divided by 1 for Sheldon. Now you could take any distance divided by any time to get this, but this will be simplified. So go ahead and do slow-mo and rocket. All right. So so these are the ratio you get when you divide the distance by the time for each of them, which is called the slope. The number that is multiplied by the variable is called the coefficient, but if you put it in this form, you can see that it's also a rate that represents the meters per minute, which we've been talking about. That slope and rate are the same thing. Remember that k could be substituted for m in this relationship. All right, Sheldon realized that the race was not really fair, so he convinces the others to giving slow-mo a head start of 6 meters. Okay, Rocket suggests that Sheldon should also have a head start of 1 meter. Okay, so the way we're going to show that is Rocket will not get a head start, so he'll still start at 0. Slow-mo will get a 6-meter head start, and then Sheldon will get a 1-meter head start. So at 0 seconds, this will be their distance. And then their speed is still the same. Sheldon goes 2 meters every second, so you keep adding 2 each second. So Sheldon should look like this, and I'll let you fill in the other 2. All right, this is going to change our equations. For Sheldon, I'll do that one. Instead of just having the slope, or his rate, times the time, we need to add the head start on there. Okay, so go ahead and write the other 2 equations. All right, so which of these equations are now proportional? and that would be Rocket, because Rocket is the only one that doesn't have anything added on. And which are not proportional, Sheldon and Slow-Mo, because they have something extra added on. They're not just something times time. And you can see that also, that they start at some number other than 0. All right. So let's make distance time graph for each turtle. Notice that Sheldon is going up 2 for every 1 second in time. Slow-Mo is going up 1 for every 1 second in time. And we don't have Rocket on here, but I'll do that in red. But he would go up 2.5 for every 1 second in time. So that'd be 2.5, 5, 7.5, 10, just like the table says. 12.5, 15. So if you drew a line through those red dots, that would be Rocket. Okay. So find the slope for each turtle. Remember, that's rise over run. So you would go up 1 over 1 for Slow-Mo. I'll put that right here. Rise over run, which is whenever we divide by 1, we just write it as a whole number. Go ahead and do the other 2. All right, now we're going to graph the other equations. And to do that, we are just going to start at a different place, and then we're going to do the slope the same way. And I'll do the first one, I'll do these lines in blue. But Sheldon starts at 1, so it's 0, 1 is his first point. And then you need to go up 2 over 1 for him. And that's going to look like those lines. Okay. Go ahead and graph for race 2. Sheldon is going to be the same, right? His equation didn't change, so we don't need to do a new one for Sheldon. That's those red dots there. But you need to do a new one for Slow-Mo. Go ahead and see if you can get that right. Remember, he starts at 6, not at 0. Now, I didn't draw a line through the dots just because it's hard for me to draw a straight line, but you would draw a line because this is a continuous situation. Okay, Sheldon's slope, you should have put 2.5 for that, and Slow-Mo slope is 1. Okay, they didn't change in the new equations. The slopes are the same, and you can tell that because their graph should be parallel. So if you look at Slow-Mo's original line, which is right here, it has the same slope as this line right here. All right, they're parallel. So remember, Rocket's graph does not change because he did not get a head start. Where did you see the slope appear in the equations? That's the number in front of x. In the equation, that's called the coefficient. Hopefully you're starting to learn that word. Where does the constant b or y-intercept show in the equation? That's the constant part of the equation, the extra added part there. Okay, find the y-intercept for each turtle. In race 1, we know they all had 0 for y-intercept because they are all proportional relationships. They start at 0. In race 2, Sheldon's y-intercept was 1. Remember, he got a 1 meter head start. And Slow-Mo's was 6 because he got a 6 meter head start. Where did you see the y-intercept appear in the equations? That is the constant part of the equation. So let's just write a little note here that this coefficient, that was the slope, and that this extra added on part, that is the y-intercept. And that's why we call this form of an equation slope-intercept form. All right, so the last thing we're going to learn how to do is how you graph. Okay. So to do that, let's take a look at the slope and y-intercept of some lines that we already know. So to find the slope, to find the y-intercept, that's pretty easy. Let's do that first. That's where it crosses the y-axis. That'd be that green dot right there. And that's 1. And then the slope of this is what we need are just some more dots, and it looks like it's following this diagonal where we go up 1 over 1. So you can just draw in a little step there to get your rise and your run, but it's 1 over 1, which we're going to write that as 1. Okay, and then when we write the equation, it'll be y equals the slope, so this part, 1 times x, whenever it's 1 times x, I don't write that, plus the y-intercept. Let's do one more together, and then I'll let you try a couple. So the y-intercept is down 5 from the origin, so that'd be -5. The slope, let's see, where's another place where it looks like for sure it's crossing? I'm going to guess right there. And so we go up 2 over 5, it looks like, between them. So our slope, and remember to look at the line and decide whether it's positive or negative, but this is going in a positive direction because as x goes up, so does y. And then the equation is y equals, put your slope in front of the x, and then you can add -5, but I'm lazy, so I'm just going to write -5 because adding a negative is the same as subtraction. All right, I'm just going to get you on started. Just remind you that when the line goes in this direction, the slope will be negative, and then I'll help you just get a couple points. You need that one there. That's your y-intercept. And let's see, what would be another good one for you to use? I don't think that one right there is good. Why don't you use those 2 points? Draw it in like that. Okay? And this one, I'm thinking they go, well, we know it's crossing right here, so I think we can be relatively sure about those 2. So use those 2. All right? Give it a shot. See if you get them right. All right, here's what I got for that. They're kind of close. Now, if you didn't count right, like maybe, let's say you got -3 over 7, don't worry so much about that. Okay? Just that you're getting, you notice this is a negative slope, so you have a negative slope there. All right. So the last thing we're going to learn how to do is graph them now that we are starting to understand this. We're going to take from the equation the slope, which we know is -4 over 3. And remember that the top number is the rise and the bottom number is the run. And then the y-intercept is 2. So we're going to put a dot at 2 on the y-axis. That's the y-intercept. And then I'm going to use the rise and run to make another point. So I'm going to go up 4 over 3, put a point. Up 4 over 3, put another point. Then I'm just going to go ahead and draw in that line. All right. Looks like I'm off a little. I'll adjust that. There you go. Okay, let's do one more together, and then you can try a couple. So my slope for this next one is -2/3. So remember, the negative tells you what direction it is. And the y-intercept is 5. So I'm going to put a dot at 5 on the y-axis. And a negative direction takes me this way. So I'm going to go down 2 over 3. Make sure you have your rise and run correctly. Okay, and then I can go ahead and draw the line. Go through those dots. All right. Why don't you try these 2, see if you get them right. Write down the slope, write down the y-intercept, and graph them. All right. If you did it right, you should get lines that look something like that. So go ahead and summarize what happened in today's lesson, and you should be ready to try some of those homework problems. If you have any questions, message me. Good luck.